Hello everyone, I'm Frank. Welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called How Shall We Split This by Marty Sears. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. Each line is divided into segments at split points to be located. Every cell lies fully within one segment. So the line is split into segments, and every cell can only be part of one segment. Each segment along the line has the same sum, but this sum can be different for different lines. Digits may repeat along a segment if allowed by Sudoku. And the digit in a green circle indicates the number. Okay, so let's first tackle what is an equal sum line, and this is essentially what the definition is. So along this line, you have to essentially split it in various points, right? So we could say something like that. Then all these three digits must sum up to what these three digits sum up to, which is also what these two digits must sum up to, right? But we don't actually know where the split is in any of these lines. But we do know that each segment must have the same sum no matter what. Digits may repeat along a segment if allowed by Sudoku. So there can be repeats. And the digit in a green circle indicates the number of split points on that line. So if this were the case here, this would have to be 2, right? Because there would be 2 split points here and here to separate the 3 segments, essentially. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Well, this is a segment line equals sum line. And it cannot be 0 for the number of segments, so there has to be at least 1. But there cannot be 2. If there were 2 segments, if there were 2 split points in this equals sum line, then all 3 of these digits would have to be the same. So this must be 1. This cannot be 7 equal split points. Actually, we know it adds up to 44. So the possibilities then, it's the rest of these digits add up to 44. That's divisible by 2, 4, or 11. Well, if you have 2 segments, that would mean that you have 1 split point. But we're not allowed that because we have a 1 already in the same row. So this must be adds up to 4, which means there are 3 split points here. Therefore, yeah, they have to be. Oh, and this 1 cannot be by itself, so the split point here has to be here. This is 3 split points, so it must be here, here, and here, because all the remaining, there's no 1 digit that can ever add up to 11. So everything else has to be 2 digits here. This is 3, and this must be 8 to add up to 11, which is 44 divided by 4. And the rest we don't know right now. These 2 digits add up to what that digit is, but we don't know what that is. It could be 4 and 5, 5 and 6, 6 and 7. It cannot be 7 and 8. It cannot be 8 and 9. So those are all the possibilities. This cannot have one split or three split points. It has to be two then, right? Because otherwise there's no other way that this can actually resolve. Well, yeah, you can't have more than three split points here. But 1 and 3 are already taken, therefore this must be 2. Which means, where are the split points? Well, if it were split here, if it were split here and here, the problem with that is that these two digits would have to be the same, which is not allowed in normal Sudoku. If it's split here, here, and here, then the problem is these two digits would have to be the same, and that's not allowed in normal Sudoku. So it must be split here and here, which means this is the same sum as this, which is 2. So therefore this must be 1 and 1. How many splits can we have here? We have 1, 2, 3, 4, 5, 6, 7, 8 cells, so it could be up to 7 splits. But that's not feasible because then these all would be the same sum. What is reasonable? How many one-digit things can we have, right? We could have one digit here and the rest be a 2-digit. Then you could have a 1-digit, a 2-digit, and a 2-digit. That's the maximum. So 1, 2 split, 3, 4. 4 is the maximum, and this must be 4 then. So one of these is 2, the other one is 1. Then we need another 2 and another 2 and another 1. So we don't know how that splits though. So this is 4 or 5. We have either 5 or 9 here, or 7. But the problem is one of these needs to be split in 2 and one of them needs to be split in 1. And if it's split in 2 with a 4, 7, that adds up to 11, which 9 does not add up to. So, and 9 is the single digit then that we have to use. So it has to be 4, 5, and 9, which forces this to be 6 and this to be 7. So we have to have another 9 here. And we have 2 sets of digits adding up to 9. Well, where are the 6 and the 7 in this box? They have to be here. So therefore, those 6 and 7s must be adding with 2 and 3 to add up to 9. But this can't be 2 and this can't be 3. So we know either 3 is here or 3 is here. Either way, if 3 is here, the 6 is one of these two. If 3 is here, the 6 is here. So 6 can never be here. The remaining digits must be 4, 5, and 8. Okay. And the remaining digits in that box, shall we say, is 4, 5, and 8. This can't be 2. So can this ever be 7? No, because if this is 7, the 2 cannot be here. So this could be 2, 7, or it's 9, 7, 2. So 7 cannot be here, but 2. Okay, so if this is 2 and that cannot be 7, right? Because if this is 2 and we try to make that 7, this would be 9 and 9, and that would be a duplicate in the same box, so that's not allowed. So this can't be 7, this can't be 7. We know 3 is one of these two. The remaining digits in column 1 are 2, 3, and 9. Okay. 9 obviously cannot be the number of split points in this line. So it's either 2 or 3. Therefore, this has to be it's either split into 3 or split into 4. We're not sure which. Hmm. Um. Hmm. We know this line adds up to 90 because it's 2 boxes worth of 1 through 9. Therefore, what does that mean? I'm not sure. Um, what are the minimums here for these split points? It could be 1, obviously. Actually, what are the possible values, I should say? It could be 1, it could be 2, because you could have 2 digits adding up each time. Or you could have 3, right? Because you could still, you could have 1 digit adding up. No, you can't have 3. If you try to have 3, how do you divide that up? You have to split into 2 and 2, and then you have to split into 2 digits, which have to be 2 segments, which are 1 cell each, which means they add up to each other. So this has to be 1 or 2. This is 1 or 2 then. Okay, what else do we have? How many segments can this be? Well, we can have a 1. We could have 5 potentially. But how many cell? 1, 2, 3, 4, 5, 6, 7. But we can only have one digit thing in this line. So that would be 1, 2, 3. So that would be a split of 1, another split 2, another split 3, and another split 4 at most, which is not 5. So this has to be then 1. So this is 1 split. We don't know what it adds up to though. What do the remaining digits in column 1 add up to? It's 45 minus 1 minus 6 minus 7, which is 31, I believe, right? Yeah, 31. Um, what can you add to it? You can add at most 8 because 9 cannot be the last digit. So that would be 39 if that were the case. So anywhere, it cannot be 2 and 3 added either. So 4 is the minimum add and 8 is the maximum. Actually, can't even be 4 because that's 4. So this is 5 through 8 here. So again, this adds up to 31. This, so 31 plus 5 is 36. So it could be 36, 37, 38, or 39. If it's split in 2, it can only be 36 and 39 that it adds up to. If it's split in 4, it can only be 36 that can add up to. So this must be then 5 or 8, right? Because we have 31 plus 5 adds up to 36. 31 plus 8 adds up to 39, which is divisible by 3, because each segment would be 13 in length. But if we had it divided by 3 with an 8, how does that work? Because 4, 5, and 8 adds up to 17. Huh. Actually, in general, I'm not sure how that works. Because we have to have 4, 5, and 8 there. Huh. Huh. Wait. Okay. Yeah. So if we try, okay, let's do it the another way. 36. How do we get 36 divided by 4? You would have to have each segment add up to 9. But the problem is 8 can only add up with 1 to add up to 9, and 1 is not on this line. So that's not feasible there. So it cannot be divided by 3. It has to be divided into 3 segments, each of which are 2 in length. Well, either it's if we have 3, 4, 5, 8 there, that adds up to 20. But 20 divided by 2, um, I guess it could be 22. Even then, that doesn't really work. Right, so okay, if this is 3, and this has to be a 9. So then the 9 plus 5 would be 14. 14 times 3 is 42, which is too big of a number. That doesn't add up. So this can't be 3. Even if we had 9, if we had 9 and 8, that's even bigger. So 17 times 3 wouldn't work either. So this can never be 3 here. This must be a 9, which makes this a 3. That's 3 in the corner. We celebrate because, I don't know, we're kind of getting close, I guess. And then if you break this down into segments, right, this adds up to 26, which means that it has to be 3 segments of 13 each, right? 26 divided by 2 could be 13. So this has to be 4. These are both 5 and 8. So the segments are specifically here, here, and here. And then this has to be 8. What digits are these? They can be specifically 5, 6, and 7, I think, right? The remaining digits here are 5, 6, 7, 4, 5, 6, 7. But 4 cannot be here. Okay. um, right. So again, this has to add up. Okay, so this adds up to 1 plus 4 plus 7 times 2. 4 plus 7 is 11 times 2 is 22 plus 1 is 23. It must be even. So this is an odd value, which means this must be odd. Okay. Huh. This is a 1 here, so this can't be 1. So this is 2, but this is 1. Okay. Um, hmm. This can't be 1, 2, or 4. It's at least 3. So again, this adds up to 23. We have one segment. This is at least 3 and 6 because 23 has to add up with another odd digit to add, or an odd sum to add up to an even value, which you need to have because this segment's divided into this line's divided into two segments. So this is at least 30 if it's 3 and 6 added to it. It could go up to 17, which would then be 40. So the segments are 20 each. So it's 15 to, the segment size is 15 to 20. Segment sum is 15 to 20, right? Because this is again 23. 4 plus 7, which is 11 times 2 is 22, plus 1 is 23. You could add 9 to it, which is 3 and 6. That would be 30. And then you could have, or add 17 to it. Wait, no, that's, if you add 9 to it, it's 32. So it's 16 into 20 are the sums. 16 to 20 are the sums. Okay, well, what are these combinations? This can be at most 14. So this has to be at least 4 digits. But if we try to have all 5 digits, that's 23, which is greater than the sum this could be. So the breakpoint has to be here, right? And it adds up to 16, 17, 18, or 19. We're not sure which. This adds up to 90. And how many segments can you have? Well, 90 divided by is divisible by 3, but you can't have 2 split points only, so that doesn't work. If we tried to have 3 split points, that doesn't work either, right? Because if you have 3 split points, that means it's divides into 4 segments. 90 is not divisible by 4, though, right? If you divide by 90 by 4, you get 22.5, which is not allowed as a sum for digits. So this is at least 4 segments. It could be 4 split points, which leads to 5 segments. So the segment sum would be 18 there. It could be 5 split points, which is 6 segments. 90 divided by 6 is 15. It cannot be 6 split points because that's 7 segments. 90 is not divisible by 7. Cannot be 7 split points because 90 is not divisible by 8. It could be 8 split points because 90 is divisible by 10. Sorry, by 9, which would be a value of 10. And it could actually be 9 split points because 90 is also divisible by 10 with a sum of 9 for each part. Huh, that's pretty wide. Okay, what are the possibilities here? To add up to 16... Okay, can you ever add up to 20? No. You can only add up to 19 at most. So it's 16 to 19, right? Because if you have 1, 5, 6, 7 here, that's the highest you can get for this four cell segment. And that's 19. Okay, so 16 would have to be 1, 4, 5, 6. And then this would be 7, and then 3 and 6 there. That works. 17 17 would be 1, 4, 5, 7. This would be 5. And this would have to be either 3, 9, 4. It cannot be 4, 8. 3, 9, or 5. No, it can't be 3, 9. 3, 8. Or 5, 6. Because you can have repeats. Oh, wait, not 5, 6. Hold up. 4, 5. This is 6. That's why. That's why I was getting confused. It could be 3, 8. It could be 5, 6. Added with 6 to add up to 17. If it's 18, it's 1, 4, 5, 1, 4, 6, 7, and this is 5. So that's what add up to 13. Could not be 4, 9. It could be 5, 8, or 6, 7. And this could be 1, 4, 5, 1, 5, 6, 7 to add up to 19, which makes this 4. This has to add up, so it could be 5, 9, or 6, 8. So that could be any of them also. Not that helpful. Okay, this must be divisible by 3. This must be divisible by 3 because it's split into 3 segments, so it's 3 times a number. We know this adds up to 11. So for this to be, this is divisible by 3. This also must be divisible by 3 to add up to another sum that adds up that is divisible by 3, which is 45. This is 11. 11 plus 1, 4, or 7 have to be, would give you a sum that's divisible by 3 here. So this has to be 4 or 7 then, right? If you have 11 plus 4, that's 15, which is divisible by 3. 11 plus 7 is 18, which is also divisible by 3. And everything else doesn't work. So this has to be 4 or 4 and 7 also. Well, these 3 digits have to be odd combined to add up to an odd digit, right? Because we know this is essentially 2 times a value. So therefore, it's 2 times, it has to be an even number for this sum of these 6 cells. Therefore, to add up to an odd number, this has to be odd. We know this is 11, which is odd, so this must be even to add up to an odd number to make this all odd. So this must be 4, which makes this a 7. This can't be 2, 9. So this has to be 5 and 6, and this is 2 and 9. Therefore, this adds up to 15. We know these digits must add up to then 15 each also. You could have 7 and 8 separate from 1, 3, 5, and 6. Or you could have 2 sets of 3. We're not sure. Anyways, the remaining digits in row 2 are 3, 5, 7, 8, 9. These cannot be 5 or 7 because of the 5, 6 pair in the box and the 7 in the box. These can't be 9. So we have 2 segments here. Sorry, 2 split points here, which leads to 3 segments. What do we have then as a total? This is 18. So 45 minus 18 is 27. So each segment adds up to 9. Is that right? Yeah, I think so. Um, let's see. Yeah, 1, 2, 3, 4 is 10. 8 and 9 is 17. That's 27. Divided by 3 is 9. So 9 has to be in a segment by itself. 2 could be in a segment with 2 and 7, 1, 2, 6, or 2, 3, 4. Well, 7 is already taken, and 6 is taken in the box, so it cannot be 6, 1, 2, 6, 2, 7, or 1, 2, 6. It has to be 2, 3, and 4. So this is 2, 3, and 4, and is a segment by itself. If we try to have an 8 here, it has to be with 1 to add up to 9, but 8 cannot be here, therefore this must be 9, which makes this an 8, which makes that a 1. So the segment is here. This cannot be 9. This can't be 9, so this must be 5, which makes that a 9. That makes this 2 and 7, which makes this 6 and 3, so therefore this must be a 9 to add up to 9. So this is a segment, this is a split point, this is a split point, and this is a split point. So it's 1, 2, 3, 4 split points there. This can't be 6 or 7, so this must be 5. This cannot be a 3. So these can't be 5. That's interesting. This can't be 3. That means this is at minimum. Oh, this can't be 6 either. So 8 has to be here in one of these two digits, because the other digit is odd. And again, remember, this is an odd sum. It must add up to an even sum because it's two segments, which means it's divisible by 2. So this must be odd. And the odd has to have one odd and one even for two digits. So the only even digit here is an 8. So this is at minimum 5 and 8. This could be 7 and 8 or 8 and 9 here. Well, it cannot. It could be 8 and 9, yeah. Oh no, cannot be 8 and 9. Because we ruled that out already, because then you would have to have 20 here and then 20 here. But this can at most add up to 19. So this cannot be 9. It's specifically 5, 8, or 7, 8. Okay. Well, if it's 5, 8, that's 13 plus 23, which is 36. Divided by 2 is 18. So if this is 5, 8, yeah, 13 plus 23 is 36. Divided by 2 is 18. So this would have to be a 5, but we know it can't be 5 because this is a 5. So this doesn't work. So this has to be 7 and 8, which means this adds up to 23 plus 7 and 8 that's 15, is 38. Divided by 2 is 19. So 7 and 8 must be with a 4. So this is 4, which means this can't be 4. This is 6 and 7. How many splits are here? This cannot be 1, cannot be 2, cannot be 3, 4, 6, 7, 8. It could be 5 or 9. Can this actually be 9? That would mean it's divisible by 10. We have 1, 2, and this is 15. So this as a whole is 90. 90 minus 15 is 75, minus 3 is 72, which is not divisible by 10. So this cannot be 9, this has to be 5. So there are 5 split points. 72 is divisible by 6, is that right? The remaining digits here are 1, 2, and 9 in row 6. So again, okay, so you have 90 minus 15 minus 3. That's 72. 72 divided by 6 is 12. So this cannot be 9 because that's too big of a number. That would be 14. Therefore, this must be at least 3 digits. We don't know if there's more. The remaining digits in row 5 are 3, 4, 5, 6, and 8. But this can't be 5, and it cannot be 8 here. The remaining digits in box 5 are 3, 4, 6, and 9. 9 must add up with 3 to add up to 12. Huh. This cannot be 9 here. So either this is 9, which forces this to be 3, or this is 9, which forces one of these two to be 3. Either way, this can never be 3, because if this were 3, that would have a 9 could not add up with 3 to add up to 12. And it can't be, there's no 1 or 2 here, so that doesn't work either. Same with this 9. This 9 can only add up with a 3 to add up to 12. So one of these is a 9, which means one of these has to be a 3. Because it cannot have 1 and 2, because that's not allowed anywhere else in the rest of on the line. So 3 has to be either here or here, which means this can't be 3 and this can't be 3. Can this ever be 2? If this is 2, it would have to be 5 and 4 at minimum, which is 11, or 5 and 6, which is 13, which is already too big. So it cannot be 2. This has to be 1, which means the rest has to be 2 or 9. 1, 5, and 4 adds up to 10, but then you would acquire 2 there, which doesn't work. So this must be 1, 5, and 6. And that's the segment there. 2 cannot add up with another digit to add up to 12. So this must be 3 and 9, and this must be 2, because 2 requires at least 2 digits besides itself. So this is a segment. This can't be 3 or 6. This can't be 6. Cannot be 6. 4 is one of these. These can't be 6 here. The remaining digits in row 4 are 5, 6, 7, and 8. 2 can be with 4 and 6. Actually, I think that's the only combination that it can work with, right? Of the remaining digits, yeah, it's 4 and 6. That can add up to 12. So then this has to be 4, and that's a 6, because 4 cannot be anywhere else. Therefore, this is a segment. So we have 1, 5, 6, 3, 9, 2, 4, 6 adds up to, so this can't be 6. 8 cannot add up with 5 or 7 to add up to 12. So this must be not have an 8. So this is 5, this is 7, which forces this to be 8. 8 can add up with 4 to add up to 12. So this is 4, which makes that 3, which makes that 9. This 3 means this can't be 3, so this is 4, this is 3. This 8 means this can't be 8, so this is 5, this is 8. This can't be 3 or 8. This can't be 5 or 7. This can't be 5 because of this 5, so this must be 7. This can't be 8 because of that 8, so this must be 3. The remaining digits in row 3 are 5, 6, and 8. Oops. Well, this can't be 8, and we know these add up to 15. So therefore, this has to be 3, 7, 5 added together. And this must be 1, 6, and 8 then. This can't be 6, this must be 8, and this must be 6. This can't be 2 because of that 2, so this must be 9, which makes that a 2. This cannot be 5 or 9, so it still could be 4, 8 here as a segment. Remaining digits in column 6 are 2, 3, and 9. This can't be 9, this can't be 2, this can't be 3. Remaining digits in column 7 are 2, 6, and 9. This can't be 9, and this can't be 2. We don't know where the 6 is. The remaining digits in column 8 are 1, 4, 8. This is 1 or 8. This is 1 or 4. And this is 4 or 8. And the remaining digits in column 9 are 3, 5, and 7. Okay, we have 90. It's either divided by 4, or sorry, 5, which gives you 18 per segment as the sum of the segment. Or it's divided by 8, which gives you... So it's actually divided by 9. So that would be 10 per segment. Okay, the problem here, if this is 8, is that this would have to be 2. This would be then a 1. But 1 with 3, 5, or 7 never adds up to 10. So this cannot be 8. It has to be 4, which makes this 1. This is 8. Each segment adds up to 18, right? Because it's 90 divided by 4, or 5, which is 18. So this must add up to 18. It could be... If we tried to make this 2, that doesn't work, right? Because if you have 4, 2, 8, that leaves us with 14, which we need another 4. And that's not allowed with 1. It has to be 1 or 3, but that's not... We don't have that available. So this has to be 6, which makes this 9, which makes that 2, which makes that 9. Therefore, this is a 3, and that's a 2. So this is a segment, 18, that adds up by itself. We have 3, 5, and 7 here. That adds up to 15. So plus 1 plus 2 is 18. And then we have 9 and 9. That adds up to 18. So we have 1, 2. This cannot be 3. This cannot be 3. Therefore, where is the 3 in column 9? It has to be here. This could be 5 or 7. Remaining digits in row 7 are 1 and 7. Therefore, this is 2, 3, 1, 7, which adds up to... This can't be 1. This must be 7, which makes that a 1. This 7 means this can't be 7, so this is 8, which makes that 7. 1, 2, 3, and 7 adds up to 13, so it needs 5 more. So it has to have specifically 5 here. Which means this is the end of 1, and this has to be 4, 6, and 8, but these can't be 8, so this must be 8. This 5 means this can't be 5, so this is 6, which makes that a 5. This has to be 4 and 6, which makes that not a 6, so therefore it's 7, 6. This can't be 5, so it's 7 and 5. That's how we solve it. Pretty cool, actually. I liked the use of this logic to restrict things, but yeah, it could have been much more difficult. I could see it. Though I don't know how solvable that would be if it were that much more difficult. But very clever use of the equal sum lines and these green circle things, which indicate the number of split points. It's very cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.